Hello. Welcome to Basic SU training. So as with our other courses, one of the things that we'd like to point out is that there's obviously a need for not only our SU team members, but for everybody else that interacts with our SU members to understand how we do things, to understand how SU works, and understand how to interact with it. So in this module, we're going to discuss basic EM theory. Later on in Module 2, we'll talk about EM methods. And in Module 3, we'll talk about using some of the more exotic tools for EM locating. So, basic tools of the trade. So the basic tools of the trade are electromagnetic locators, and each one of these images here are examples of some of the electromagnetic locating instruments that we use. So, pardon me. So all the pictured devices that you looked at essentially perform the same function. So what it amounts to is they impress a signal on a cable. Has to be a conductive facility, and that being a cable, a metal pipe, an object that has a tracer wire that we can impress a signal on, and so on. So all of those systems that you saw basically do exactly the same thing. The difference between them basically being output wattage, the type of frequency that they use, and then some of the ergonomics about how you hold it and whether or not it provides certain information on the screen. Some of them have very unique frequencies. Nowadays, frequencies really aren't proprietary, if you will, but kind of in a traditional sense, these manufacturers have all kind of maintained the frequencies that have been their kind of historical stuff. And at some point, back in the day, these frequencies were proprietary to each one of the manufacturers, and that has, of course, changed. Some of the systems that we looked at are single frequency, some are 2 or 3 frequencies, and then top of the line stuff is what we call multi-frequency, because essentially you can program them to receive any frequency, but there's some caveats to that, and we'll go over that. Essentially, one of the big issues is, which system do you use, and then why? Why do you decide to use it? Well, a lot of that comes into figuring out what type of work you're performing. What kind of designating work are you performing? What are the target facilities? What's the average depth? How long of a locate do you need to perform? And like we say here, of course, there's some personal preference involved. So, single frequency systems. So the original up here in the upper left-hand corner is the Metrotech 810 Classic, which is kind of the gold standard. This is one of the very first locating instruments out there. Kind of the old school, traditional, if you will. This system is analog, non-digital, operates on a 1/4 watt of power, and incredibly effective. Runs at a frequency of 83.075 kilohertz. And that'll be important a little later on. Next to it, the Subsite 830. And one of the interesting things that you'll note through each one of these things, the Subsite, the Severin 830, the Metrotech Digital 810, which is essentially the digital version of the original analog 810 Classic. Over in the lower right-hand corner is the Vivax VM810, which is now Vivax and Metrotech are now merged. They're one and the same company. So this is basically the digital version of the 810 now in the Vivax close. And then in the middle here down below is the radio detection RD5000. The one thing that all of these systems pictured have in common is that they're all 83.0775 kilohertz. They're exactly the same frequency because they realize that that frequency operates very well, especially when trying to locate, for instance, ductile iron water lines, because 83 will jump the gasket, will bridge the gasket so that the signal can continue. The next systems we have are what we call double and triple frequency systems. So there's the Leica DigiCat, which you don't see very much here in the States. This system right here gets used a lot in Europe. I don't know why, but it tends to be their favorite in Europe. The Metrotech 9860 and 9890, and the difference between the two model numbers was the 9860 is 2 frequencies, the 9890 is 3 frequencies. The Dynatel 2250 is a 3 frequency system, and the Subsite Utiliguard is a 3 frequency system. Then we have here our multi-frequency or programmable frequency systems. So the Dynatel 2220M, M stands for multi-frequency. The Vivax VLOC Pro 2, and now there's a Pro 3 out. Multiple frequencies, programmable frequencies, and so on. The Rigid SeekTech SR20, multiple frequency programmable system, omnidirectional antenna system, very effective for locating sondes and some other things. It's an instrument that's a favorite of a couple of our guys here. And then the radio detection RD8100 is the unit that we use here most often. This is a very advanced system, GPS built in, has a hard drive built in. It records everything that the unit does. Once every second while the unit is turned on, it records 40 parameters for later analysis. It's a very interesting setup. So Pipal Cable Locator is an electromagnetic instrument. It uses electromagnetic waves, which are AC current, alternating current, to impress a signal onto a pipe or a cable composed of a transmitter and a receiver and some connecting cables and all the stuff that goes along with that, the signal generator, battery, speaker, blah, blah, blah. Very portable. The electromagnetic energy generates a magnetic field around something that's buried conductively. The receiver basically receives that signal from the magnetic field and then gives you some sort of indication, whether it's visual or audible, showing you that you're in proximity to that signal, and then when you are closest or most correctly aligned with that signal. The other thing that they have in common is almost all of these have the ability to what we call induce a signal. So essentially that means that it will broadcast a signal from the transmitter box without having to have a wire or cable hooked up to the target facility. So the other thing that needs to be noted is that these systems work great for metallic utilities and utilities that have some sort of tracing wire on them, or where we have like an empty conduit where we can put a metallic conductor or a beacon sonde through the empty conduit. But the other thing is that non-metallic utilities will not be detected with this type of instrument. So we won't, the question I think here is pretty obvious. What utility is the electromagnetic system locating? And the picture is, showing you, it's indicating that it's locating that central facility. So one of the most important things to remember is that electromagnetic systems, very important, they do not locate utilities. Let's make that very clear. They do not locate utilities. What they do locate is the signal that is being carried by that utility or that tracer wire. So it locates that electromagnetic field that is being carried by the facility itself or the tracer wire that's associated. So let's resume. The EM locator designates the path of the magnetic field. It locates electromagnetic fields, not utilities. So one of the big things that we have in SUE is people saying they locate utilities, and the idea that the activity is called locating utilities, definitely a misnomer. We designate the path of utilities based on the location of the electromagnetic signals, and this is exactly why we call it designating. In the practice of SUE, the term locating means that you have physically located it by exposing it and confirming its horizontal and vertical position. So when we say designate, means that we are designating the horizontal path, and when we say locate, it means that we have vacuum excavated, we've dug it up, and we've physically located it. So electromagnetic signals are propagated outwardly from the facility. So if we're hooked up to a facility, we're generating electromagnetic signals, and in theory we like to refer to it as a round signal, and they propagate from the facility itself out in concentric circles, and this is what allows the unit to pick up the information and allows us to designate the horizontal path of the utility. The issue then becomes whether or not you have a round signal, and a round signal basically means that it's concentric around the utility, that there's no distortion. A non-round signal would indicate that you have distortion, and then that would potentially throw off the accuracy of your designation. So when you have two facilities that are side by side and both of them are conductive, or one of them is conductive and the other one isn't, it doesn't really matter. The idea that two facilities are buried in the ground side by side with one another, they both have the propensity to distort the other one's electromagnetic field. And so you can see here that the concentric circles that start out from the two different facilities then start to merge and become distorted and oblong and create a hump and so on. And this is where you have to come back and do some additional diagnosis to understand why you have a distorted signal. And typically this is a clue for designators that there is an adjacent facility that needs to be investigated. So it's very important to understand how to differentiate between round and non-round signals, and how to understand whether or not you have a distorted field. And there's a number of ways to do that, and the ways to do that generally involve checking variables in your depth calculation that's displayed on the unit, and using other methods like null locating or triangulation to ferret out what is the proper signal. So every geophysical technique has limitations. There's no magic bullet out there. There's no single geophysical system or technique that works right in every situation. There are soil type issues where we have conductive or corrosive soils that will interfere with the electromagnetic field. There's geological conditions that you might have to deal with. Pardon me, the presence again of other underground facilities. But the idea is you should be able to ferret out these pieces of information if you follow the proper steps and do a little bit of homework. So here in bold, we have some important statements. So qualified SUE consultants that are familiar with all geophysical techniques are necessary for surveying underground utilities and interpreting the results of those surveys. Unqualified SUE consultants can result in the need for another survey and can create some serious problems for a project and the idea of undiagnosed or unreported conflicts. So there are some ways to utilize the electromagnetic equipment to apply a signal. And in this particular graphic, this is a direct connection setup. So we have a clip that is directly clipped to a conductor. We have the box as the transmitter here, and then we have a grounding stake. And the idea is, as best as possible, to maintain a 90-degree separation from the line or supposed line of where your cable or conductive facility is to the grounding stake. Because we also have in our work what we call ground path return. So in basic electromagnetic theory and in AC current theory, electricity is always looking for a ground. It is trying to find a way to ground itself out. It is heading for a ground no matter what you do with it. So the idea is you want to separate your grounding stake as far as you can physically, based on the limits of the amount of cable that you have, and at that 90-degree angle, so that you are not accidentally receiving, on your receiver, your ground path return, that you are actually locating your target. And with proper diagnosis, you can understand if you have somehow moved over to your ground path return. So it takes a little while, it takes some training to understand how to do that, but it is possible to diagnose that issue. So the method that we talked about a moment ago, and I just showed you the graphic on, is called direct connection. In this method, this is what we call dropping the box, or it's an inductive method. So each one of those transmitter boxes has the ability, without any cables connected to it, to propagate a signal from the box. And if you understand which direction the signal is being propagated from, and each one of those boxes has a clue on it as to how the antenna is configured, you can drop the box above a conductive facility and it will induce that current on the facility, and you'll be able to receive it with the receiver and designate the location or the horizontal pathway of that facility. Another way is inductive clamp or clamping. So the majority, if not all, of these transmitter systems have the ability to connect a inductive clamp to them. So you don't need an independent ground. Essentially, you just plug it into the transmitter box and clamp the clamp around the target facility, around the cable, around the conduit, and it will induce that signal. It's also important to note that there is a signal direction here, and that we'll go more into signal direction in Module 3, but there is a signal direction, and the signal always propagates out and away from the transmitter. So that'll be important later on. So we've just reviewed three methods. We reviewed conductive, direct connection, inductive, dropping the box, and clamp inductive, adding a clamp or using a clamp to induce a signal. Of those three methods we just reviewed, which method do you believe is the most reliable? So, direct connection is the most reliable because you can more tightly control the signal that is being induced onto that system and more correctly follow that horizontal pathway with direct connection. Of those three methods, again, direct connection, induction, clamp induction, which method do you think is the least reliable? So inductive, dropping the box. And that's mainly because you don't have much control over the signal itself, and you don't know whether or not you are bleeding off on another system. You can diagnose that. We'll cover that again in another module. But of the three methods that we just reviewed, which of those methods, do you believe is the most accurate? Again, direct connection, inductive, clamp inductive. Which do you believe is the most accurate? So it's a trick question. They all are very accurate if they are done correctly. So that's it. That's the basics of Module 1, horizontal designating for Sioux.